Welcome to this very beautiful tutorial. So in this tutorial, we're going to be learning the variable and constant, right? The variable and constant you see. So before we start, we need to create our folder for this course, right? So I will go to my, because right now I'm using Windows 11. So I will go to my local disk here. So I'll create a new folder. Let's call this one standard C. Now, remember I said in my previous video that I'll be using Visual Studio for this course, right? So I'm going to be sending the video. I'm going to be uploading the video on how you can be able to install the C compiler, the compiler on Windows OS, right? So that you can start working with it on Visual Studio. So I'll go to click on my file, so open folder. Then I'll go to my local disk and then look for standard C. Okay, so now this is it. So let me confirm if the C is actually running, right? So I will click on this file here. So let's use hello.c. So I will start with the header, include this std, yes, include this. Then I have my main method, include the main. So let me try and see print hello world. Print hello world. Hello world. So return 0. Now this return 0 is not a must, right? So in modern C by default it's return 0, but in old C you have to do this, right? So even if I didn't put this, let's see what happens. Even if I didn't put this return 0, so let's see what happens. Let's see if this is modern C. And let me click on terminal and then new terminal, then gcc hello.c, then the output, that is -o, and hello.exe. Then to run this is hello.exe, hello world, right? So you can see this is actually the modern C, but let me just put 0, right? Just imagine it like this. Okay, so it will still run. So if I compile this back, do this. Okay, hello world. Now it's running. So let's go to our slides. So I'll start the lecture. So we're going to be learning variables and constant using C. I'm going to be learning some logical operators. I'm going to learn so many things here in this model 2. Now, what is a variable? A variable is a name memory location used to store data that can change during program execution. Now, the characteristics of a variable. So the first one here is they occupy memory in a computer. Their values can be modified at any time, and each variable has a data type, a name, and a value. Or we can say, in a layman's term, a variable is like a container that holds a value. Now, let's look at this example. So we have variable declaration or combine. So you can see this is the combine, and this is the variable declaration. So this is the declaration, and this is the initialization. So we have a variable called age, and this age is holding an integer data type. So you can see that this variable is explicitly declared, right? So you can see the int is explicitly declared. In some languages, this is implicit in nature, where if you have age equal 25, the interpreter, like Python, understands that 25 is actually an integer data type. But in programs like C, Java, you need to explicitly declare the data type so that the compiler will understand that the variable age is holding an integer data type. Now let's look at some variable naming rules. So a variable name must start with a letter that is uppercase or lowercase a to z, or you can start with an underscore but cannot start with a number. Please take note, a variable cannot start with a number. So after the first character, you can use letters, digits, underscore, right? After this, right, you can use letter, digit, underscore, but you can actually start a variable with this, right? Now let's look at other ones. So a variable name cannot be keywords or reserved words like the int, float, return, if, else, for, and while. Now, if variables are case sensitive in C, so no special characters and no space allowed. Now let's look at constant. The constant is a value that cannot change once defined. Why is the need of using constant, right? So it prevents accidental modification, it improves code readability, and is used for fixed values. Right, I can see this an example. Most of the time, our naming rules for constants is mainly uppercase, right? No lowercase, mainly uppercase. But it's not that it's a must that it must be uppercase, but most times we use uppercase for constant. So let's look at data type. We need to understand data type, we need to understand the primitive data type, we also need to understand the non-primitive data type, which is also called the reference data type. Now, a data type specifies the type of data a variable can hold. All programming languages classify data types into primitive, which is a basic data type, and also the non-primitive reference, which is the reference data type. Now, let's look at primitive data type. Now, primitive data types are the basic built-in low-level data types provided by the language. They store simple, single values and are not made up of other data types. So what are the characteristics of the primitive data types? So the first here is built into the language, store simple fundamental values, occupy fixed amount of memory, is faster to process, and usually cannot be broken down further. So before we start programming, we need to understand what are the primitive data types. We need to understand the logical operators. We need to understand the mathematical operators, right? So now let's look at the primitive data types, which are the integer, the float, the double. So the integer is a decimal, so the double is a large decimal, right? Then we also have the character, which is a single character, the char, which is a single character. We also have the boolean, which is true and false. Now let's look at the non-primitive data type in C. So non-primitive data types are not built in at the lowest level. So they are created using primitive data type or constructed by the programmer. So let me use, for example, let's say if I have, let me use another one because this is C. So let's create another one. Let's call this one example. Example.c. Example1.c. Right, so I will start with the header, include std this. Now int main this. Now this is a primitive data type, so let's say age. So this is a primitive data type integer. Let's say integer is holding 7, right? 7. Now we can actually create a non-primitive data type of an array from this, like to hold integer values, where I have something like this, right? So this becomes this. So this becomes a variable that's holding an array of numbers like this, right? So that's why we say that they are created using primitive data type or constructed by the programmer. Another good example is something like this. If I have a car like this and car is X, which is holding single character like this, D, right? Now if I want to create a string from the character, I have to do this. So the string, it has to be a combination of these values here, right? So that is what combination of these values here. So I have to put more letters here. So that is what we're trying to say here. So that is what we're trying to say here, is that they are created using primitive data type or constructed by the programmers. So they usually store complex data or multiple values. So we'll say the characteristics of non-primitive data types is they are created from primitive types, can store multiple values, can be of varying size, sorry, more complex and slower to process, often require more memory, and allow structures and relationship. Now let's look at some common non-primitive data type in C. So we have the string, right? Just like what I did here, right? So I said this is a primitive data type, which is carried. Let's say the variable is S, and this is holding a single one, right? Like this. So if I want this to actually hold a string, I have to put a box, a square bracket here, and then I'll add this docs. right? So you can see how we created non-primitive data type from a primitive data type, right? So that's what we mean by this. So we have an array, which I've demonstrated that an array stores multiple values of the same type. We have the structure, so the structure stores different types of data in one unit. We also have the pointer, so we'll be looking at array structure. As we move on in this lecture, we'll be looking at this, we'll be expanding on this, we'll be doing some examples on this. So old memory address of another variable, and the union is similar to structure, but share the same memory space. Then the enumeration, which is the enum, is user-defined types with name integer constants. So we're going to be working with all these non-primitive data type. We'll start with a string and array first, then before we move to pointers, and then we'll look at structures, union, and enumeration when we're solving some basic problems, right? So let's look at the difference between primitive and non-primitive data type. So for the primitive data type, is fundamental, is basic, it has a fixed size, it stores simple value, is fast and efficient, and is provided by language and cannot be broken down. Then for the non-primitive data type, it is complex types created from primitives, size may vary, it stores collection of structures, slower but more flexible, is defined by programmer, which is higher level, and can be composed of primitive. Now let's look at the different format specifiers for different data types in C. Now you can see the int, right? So you can see this is a format specifier. So without this format specifier, it cannot actually print an int value. Now let's look at an example here. So I have this, right? So okay, let me go back to the primitive data type. So I have int age equal let's say 45. So printf. Now if I do this age, now this will actually print out not the it won't print out anything because the compiler is not actually seeing this. The compiler will only see this if I do this, right? So let's try to do something. So we have the example one is so let's run this. So gcc example one, let's see the output, then example one that's exe. Then let's run this example one.exe. Nothing happens, right? So the only way you can be able to see this is when we do this. So let's run this again. Do you see it now? So that is how it works. So you can see we have for int and we have for float. This for float. We have for double. We have this for double lf. Then we have for character, which is C. Then we have for string, which is S. So you have to be familiar with the format specifier when you're using C to print out something, to print out the result. So you have to be familiar with the format specifier. Yeah, let's look at some operators in C, right? Now, operators in C, we have the addition, subtraction, multiplication, division, and modulus. So we can call this a remainder, right? Modulus or the remainder. So you can see we know the simple addition, the simple subtraction, we know the simple multiplication, we know the simple division. Then when it comes to this A modulus B or A remainder B, so let's assume that A is 4 and B is 2. So 4 remainder 2 is actually 0 because 4 divided by 2 is 2, remainder 0. So that's the remainder is 0. So that is how it works, that is how the modulus work. Right, so I think I was explained this in my previous lecture in module 1. So let's look at the relational operators. So we have some relational operators in C, which are the equal to, trying to compare two variables together, right, or trying to compare two values together. Then we have not equal to, then we have greater than, we have lesser than, we have greater than or equal to, and we have lesser than or equal to, right? So these are the relational operators. Now let's look at logical operators. So we have the AND, these are specified in C, right? We have the AND, which is AND, so it's true if both conditions are true. Then we have the OR, like this is a sign, this is operator. is true if either condition or both conditions are true. Then we have the not, is how we specify the not. It reverses the value, right? Reverses a value. So we'll say not A is actually reversing the value of A, right? So now let's look at the input operation. The input operation. Now, the input operation uses what we call the scanf function to collect user input. So let's do an example. So you can see this an example here. We have a variable which is age, is of integer, is holding an integer value. So we are displaying enter your age. Then this scan is to collect this age, right? And then we now have another print that will print out the age. So C needs memory address of the variable to store the inputs. That is this and. So this and here, right? This sign, it means that C needs the memory address of the variable to store the input. So let's work on this. So let's do a little bit of example here. So I have, let me put age, input 32. Then let's say printf. So this is just a string. So I will say please enter. Okay, for now I want the user to enter the age, right? Please enter your age. Then I need the input function, which is scanf, right? So because it's an integer value, right? So I have to specify this. This is specifier, right? Then I have to include this, then age, right? Then I have to show the printout. You can say the age of the person is, then I'll put the age. Okay, let me return 0. Okay, so now let's work on this. I'll compile this again, then I run this. So please enter age. Let's enter 45, or let's enter 32. So you can see the age of the person is 32. Right, so if you want to make it find the person is 32 years old. Right, so if you print out this, let's compile it again. Do it again. Let's run it. Age 32. You can see the age of the person is 32 years old. So when you put this here, so this is actually fetching this integer value, right? So that is what it means. This percentage D is what is fetching this integer value into this. So that's why I have the age of the person is 32 years old. Right, so you can see how simple C is. So let's look at some other function. So we have done this, right? We have actually done this, and let's look at, okay, now you can see how we run this. So the GCC actually stands for the GNU compiler collection. So it is the C compiler that translates your human readable C code into the machine code that the computer can run. So without GCC, you cannot turn .c file into .exe, which is a Windows or binaries, right? So that this is an output, right? So this stands for output. So it tells the compiler the name of the executable file you want to create. So without this, GCC will create a default executable called a.exe or a.out for Linux, right? Now let's look at some operator precedence, right? You need to understand operator precedence when actually working on mathematical operations, right? So many students get actually got this wrong, but if you remember your board maths, you can be able to understand this. Now, operator precedence tells C which operator to evaluate first when an expression contains more than one operator. Now let's look at this. We have a variable called x, and this is equal to 5 plus 3 times 2. Now, what happens first? With your board mass, multiplication comes first before addition, right? So that is how the computer processes the same mathematical operation. So the multiple operation here is the first thing we need to do is the 3 times 2, which is the multiplication, and then addition will be 5 plus 6 because times has higher precedence than plus. Now let's look at some of the precedence here so that you can be, please familiarize yourself with this precedence, right? So you can see the first one, if there's a bracket or if there's a parenthesis like this, that is the first thing that will first execute. And first of all, move the bracket, and then these are the second ones, like the multiplication, division, and then the modulus. Multiplication, division, and modulus, they are the second highest level of the operator precedence. Then number 3, we have the plus and the minus, or plus and subtraction, or addition and subtraction. Then the fourth one here, we have the lesser than or equal to, greater than, and greater than or equal to, right? Which is the relational. Then we have the number 5 is equal to and not equal to, right? Then we have number 6, which is and, right? And then we also have the or, which I didn't actually put it here, so we didn't put or here, but there's or. Then we have the equal assignment. Now let's do some practical example here before we close this module 2 lecture on operators, right? Let me call this example 2 dot c. So let's put include stdio h is the header, so this is the main method. Okay, now let's do some calculation here. So if I have int a equal 3, int b equal 5, int sum equal 3 plus 5. Okay, no, a plus b times a. Now, what will be the answer here? So the answer to this is b times a is what? B times a is 5 times 3, which is 15. So 15 plus b is what? B is 5, a is 3. So 5 times 3 is 15. Then 15 plus 3 is what? Is 18. So let's look at this. Let's confirm if this will be correct. So I'll print printf d. Sorry, so return 0, right? So let's compare this. So we have the GCC example 2, the output example 2, the exe. Oh, did I do something wrong? Okay, I did something wrong here. GCC.c. Okay, then we have this example 2.exe 18, right? Now let's look at this operator precedence again. Let's find out something. Now you can see that the second highest precedence are times divide modulus. Now let's see what comes up first when we try to do these two, right? So let's assume this is a times this and this divided by this. Now because we are using int, right? So let's see what happens if there will be an error, if there will be semantic error. Remember in last class we explained semantic and syntax. So let's see something. Let's see what happens. It's in 5, right? You say the answer is 5. Let's look at this. If you look at the precedence here, times comes first, then divide comes next. So let's confirm if this works. Now a times b is what? A times b is a is 3 times 5 is 15. Now 15 divided by 3 is 5. Cool, right? So let's do this. What if is like this? So it means, will it be b, which is 5 times 3, right, is 15. Then a is 3 divided by 5. So let's see if this will give a semantic error. Yes. Yeah. So let's look at this. B times A, B is 5 and A is 3. So 5 times 3 is 15, right? 3 divided by 15 is what? So it's supposed to be 0 point something, right? Now it's actually giving the whole number. Why? Because integer data type cannot hold decimal numbers. So to be able to play safe to do this, what if I do this? Float, right? So I can see the answer. Then now, because it's a float, right? I have to put this. And let's see. It's actually giving 0.00000. It's not actually bringing, fetching anything, right? And this is actually a problem. So let's do this. Let me use a float here. Let me use a float here, right? So this is 5, this is this. So let's confirm something. Okay. Now, because we use a float and the A is 3 and float is 5, right? So B, our B is 5, then our A is 3. So 5 times 3 is 15. Now 3 divided by 15 is what? So let's confirm something. So let's go to my calculator. So 3 divided 15 is 0.2, right? So 3 divided 15 0.2, not 1.8. So how was this calculated? So we have A equals to 3, then B equal to 5. So let's do this. That's 3 divided by 5. So let's do 3 divided by 5. 3 divided by 5. 0.6. Then our A is 3, right? 0.6 times 3. So 1.8. So this is how it's calculated, right? So it doesn't matter whether the multiplication be 1 first. So in the higher precedence, what it means that in the higher precedence here, whether the multiplication is first, so anyone that is first here, that is what it's being executed first, right? So now if we do this okay, let's leave this first. So what it means here is that you can see these two are of the same precedence, right? So that's why I executed this first before I executed this. So even if we have multiplication here and we have division here, it will first of all execute this before I execute this. So it is 3 times 5 divided by 3, which will give you 5, right? So you can see how it works. So just take note of this. You can see 5.0 because it's a float, so it's returning float, which is 5.0. So you can see how it works, but just take note of this, right? So as long as they are of the same higher precedence here, the operators like times, division, and modulus of the same higher precedence, then just take note that it executes sequentially. But if this precedence comes first and this is the last, it will take this one first before it takes this. So just understand this operator precedence, understand the steps we have from the first step down to the 8th step, right? So that is what all for this class here. In our next class, we'll be looking at more, we'll be programming more, right? We'll be looking at the loops, the decision, and the repetitive decision in our next class. So thank you and God bless you.